Okay, so welcome to the sixth lab of SCI. Today we are going to recognize the igneous rocks. So first, overview for rocks. Like what I said in last lab, rocks, they are made up of minerals. In a single rock, like this one, actually it consists of a lot of minerals. According to the formation process of rocks, we can divide them into three main types. The first one, igneous rock. Second one is sedimentary rock, and third one is metamorphic rock. The igneous rock is what we are going to show in today's lab, and the sedimentary rock we are going to talk about more details in next week's lab. Metamorphic rock, this is more complex one. You are going to learn that in the week 8 lecture, but we are not going to do labs on that. So the igneous rock, they are formed by the cooling and the solidification of the magma or lava. Usually we classify them by the grain size and the composition. We have two major types of igneous rock, the intrusive and the extrusive. Like for intrusive igneous rock, is formed underground. We have very thick stratum, and the magma intrude into this stratums, but they do not come to the Earth's surface. They are still deeply underground. So this is intrusive igneous rocks. Because the underground temperature is very high, the cooling rate of the magma is very slow. So they cool down very slowly. The crystals have time to grow to very large size. One example of intrusive rock is this one, this picture. You can see the crystals. The crystal size are very large in this rock. If the lava or magma reach the Earth's surface, for example, by the volcano eruption or at mid-ocean ridge upwelling, we call it extrusive igneous rock because it comes to the air or come to the cold ocean water. So the temperature difference between the lava and the air is very large. It cools down very quickly. The crystal, the size of crystals are very small. They don't have enough time to grow to very large size. This figure is an example of the intrusive igneous rock. And also, different igneous rock have different composition, and the composition decide the color of the rock. So we can check the color of the rock and to infer the composition of the rock. For one type of rock, it has much silica. If it's silica rich, then it's felsic. Felsic appears as light color. If it's silica poor, it does not have much silica. Then we call it mafic. Usually this kind of rock appear as dark color. And if it has medium silica content, its color will also appear as intermediate between the light color and the dark color. So here we have three rocks. This one is felsic. So this one is light color, and this one is mafic. So it has dark color. And the mid one, the component is in between. So you see its color is also between the light and the dark. Yeah. So remember, color is one important evidence we use to decide the name to identify the rock. Also, we look at the appearance of the rock to check the texture. For extrusive rock, it has a lot of types of textures. Like one can be glassy. So the texture of this rock is very smooth. It can reflect the light very perfectly. So see this figure, its appearance is very like the glass. So it's glassy texture. The second one is magnetic. This one is not as smooth as glassy, but the individual grains cannot be seen with naked eyes. The rock appears as massive and without mineral boundaries. And then next one is porphyritic. This one, we can see two distinct crystal sizes, and the large crystals are surrounded by a ground mass of tiny crystals. This figure is an example of the porphyritic texture. You can see the light color points. They are the large crystals. Actually, they are the impurity of the rock. And you can see the material surrounding them has very small, very fine grain size. So this is the bulk of the rock. And we also have some vesicular rock. It's painted with many capacities, and is formed by the expansion of gas or steam during the solidification. The most important characteristic of this rock is like the weight. It's very light. It's very like low density rock. Like for this one, it's a very large rock, but its weight is very light. For the intrusive rock, the texture is always phaneretic. So in this rock, you can see individual grains, and the crystal size is very large in this kind of rock. Yeah. So yeah, so see, this is granite. This is one kind of intrusive rock. So you can see the crystals on this rock. But for this one, this is one type of extrusive texture. On the surface of this rock, you cannot see any like crystals. Here is the simplified version of the texture. For extrusive texture, the grains you cannot see in any portion of the rock. For this, like these points, they are the impurity of the rock. They are not the bulk of the rock itself. And sometimes very special texture like bubbles, glassy. For intrusive texture, the crystal making up the entire rock, and it's large enough for you to see. And sometimes you can even see the cleavage on their surface. So for intrusive texture, you can put it under the light. It will reflect the light under a certain angle, just like the cleavage. This is a figure showing the texture, the coarseness of the rock from left to right increase. The coarseness increase from left to right, and some very special texture like the porphyritic and the vesicular texture. So in today's lab, from question 1 to question 9, you need to do almost the same thing with last lab. You need to match the sample with their names. We have 9 samples. So I will teach you how to do this identification. First, look at the texture of the rock. If it appears as glass, then it's obsidian. We only have one sample is obsidian and has very glassy appearance. This one. And then take a look at the color of the samples. If it's light color, the color is light, it should belong to one of these two because it's basic. And if it's dark color, it should belong to one of these two because it's massive. If the color is between the light and dark, it should belong to one of these two. And for this ultramafic rock peridotite, this is a very special rock. The component of this rock, the mineral component of this rock is almost olivine. So it has the same color of olivine. It's the green color. So this is very special. And then how can we distinguish between these two? We take a look at the crystal size or the grain, whether it's fine grain or coarse grain. If it's fine grain, you will see this kind of appearance. If it's coarse grain, you will see this kind of appearance. So like for these two, it's light color, so it should belong to one of these two. And we see the crystals on this rock, so it is actually the granite. And for this one, the light color and the fine grain, so it should belong to this one. Yeah, here are example figures of these rocks. Next, let's take a look at where these rocks comes from, the volcanoes and the lava, the magma. For the volcano, in plate boundary, we already say we can see volcanoes at subduction zone, the convergent boundary. It's called volcanic arcs on the land side part of the subduction zone. We can also see that at divergent boundary at mid-ocean ridge, but it's less common. And it can also appear at hot spot volcano, like the Hawaii island chains. This figure shows how hot spot make the volcano. We can see more details. First, the subduction zone volcanic arcs. The volcano train appear at the land side of the subduction zone, and the direction of its extension, the direction is the same as the change and the subduction zone direction. The reason for this volcano is the melting of overlying mantle materials make its way up and mix with the continental lithosphere. So we have the melting mantle materials goes up and it goes through the continental plate, continental lithosphere, and reach the surface of the Earth from the volcano. So at the igneous rock, at the lava of this volcano, you can see the mantle materials. You can also see the continental continental plates, continental lithosphere materials in the lava of this volcano. For the hotspot volcanic arc, the reason is we have a fixed hotspot. The location of hotspot is fixed, and the material inside is very hot. So the melted material goes up and form the volcano. In the meantime, the plate is moving. in this figure, the plate is moving rightward. So the old volcano will move rightward, and this is actually the extinct volcano. And we will have new volcanoes formed above the hot spots. With the plate keep moving, we will see more and more volcanoes on this tree. And the furthest one is the oldest, and the closest one is the youngest. By the appearance of volcano, the shape of the volcano, we can divide them into 5 groups. The short volcano, stratovolcano, cyclones, lava domes, and calderas. For short volcano, it's created from low viscosity lava flows, and the low viscosity always means mafic. So mafic means low viscosity. This volcano is created from low viscosity lava flows. The volcano gradually built up through the continued eruptions over a long period of time. Because the lava has low viscosity, it can flow smoothly, it can flow freely, and it will have this kind of continuous flow up to the surface. And over a long time, from this kind of shade volcanoes, the slope of the mountain, the slope of the volcano is not steep, it's pretty flat and gentle. This is the most important characteristic of these short volcanoes. If you see from the top, the map view, you will find it's roughly circular, and it's commonly associated with mantle plumes. So this is the mantle plumes here, this red line. And it's less explosive because it's continuous flow and gentle flow. For stratovolcanoes, it's also called composite volcanoes. For this kind of volcano, we see fairly steep side as the result of high viscosity and more felsic lava flows. So the lava flow here is felsic and has high viscosity. It's harder to flow. It's hard to flow. And we can see multiple vents created parasite cones. So sometimes the resistance above is too large. The lava flow cannot go from this crater. So it goes from the side vent and form this kind of parasitic cones. And you see many layers at these volcanoes. Each layer corresponds to one eruption. So we have many eruptions for this volcano. The eruptions for this volcano can be explosive, can be very dangerous because we have high viscosity lava. The high viscosity lava means higher resistance, means higher energy accumulation. If it overcomes the resistance, then the power would be very large. Next one is cinder cones, cinder cones, sorry. So cinder cones, they are typically smaller than the short and the composite volcanoes. The mountain slope, volcano slopes are also steep, and but it's formed from loose pyroclastic materials. So the volcano materials are very loose. Explosive eruptions can also occur at the central vents with lava cooling in the mid-air to form the rubble that build up the cone. For this kind of volcano, usually we only see this channel, these up channels. We don't see side channels on the cinder cone. And next is the lava dome. The extremely high viscosity prevents at the crater. So plate boundaries. Viscosity. Final one is calderas. So before the calderas, the volcano is pretty like this one, stratovolcanoes, and it has lava chamber beneath the volcano, beneath the mountain. But if this the lava flow all goes out and the chamber become empty, it cannot support the heavy mountain above. So the mountain collapsed and formed what we call calderas. One important question we want to know is what makes the volcano dangerous? What determines how explosive, how dangerous a volcano will be? The key answer is composition. The volcano has more felsic or higher silica rocks tends to be more explosive. The reason is the silica is very viscous, so it's very resistant to flowing. This high viscosity impedes the movement of magma and prevents the gas bubbles to the surface. Then the pressure built inside the magma chamber because it cannot float out. But finally, after it has enough energy, it will overcome the resistance and have this kind of explosive eruption. So these two igneous rocks, their volcanoes are more explosive because they are more felsic. For this intrusive, because it's deeply underground, usually they don't reach Earth's surface, so they are not dangerous. Okay, so for question 1 to 9, you need to match the sample index with their name. Again, we have diamonds here on the front table. And we have, like, similarly, we can do some name test. Here, if you want to know the name of this rock, for example, I choose basalt. This is just randomly choose. I can grade. It tells me the rock name is wrong. If your answer is correct, the rock name will disappear. Yeah. Also, for half of 9 questions, you can do this kind of test. For others, you can again look at the 3D model. And we have, like, in total 49 questions, pretty much in this lab. For question 10 to question 17, question 16, you need to make a plot, make a scatter point plot using the Google Sheet or using any your local sheet software. So the data is here. Here, the cascade data.csv and the resi data.csv. Here I have uploaded to my Google Drive. If you open that, you will find many data. For those ones, we don't use them. What we really care is this three, just this 3 columns. We care about the SiO2 components, care about CaO component and the K2O components. So you need to plot how CaO changed with SiO2. You choose these 2 columns and insert a chart, and it will give you this kind of scatter points. Each point corresponds to one rock sample, how many SiO2 and how many CaO it has. For the cascade data, it has much more data points. So if you plot in Google Sheet, it will give you a histogram like this one defaultly. What you need to do is change the chart type to scatter, and then it will give you the scatter point data the same as this one. And some other things. For the abstract rewrite, if you haven't get approved, you can like find your abstract in this class and call me to approve your abstract. And we have get the midterm exam paper back. If you want to pick up the paper to take a look at the question details, you can come to the table to get them. And sorry, a final reminder. If you want to submit any figure on Blender, please use either JPG or PNG or PDF. Do not use HEIC. It cannot be opened without an Apple machine. So use